Hi, this is Professor Marianne Barber. Example, evaluate the integral dx divided by the square root of the quantity x squared plus 4x plus 7. In order to solve this problem, we will need to first complete the square of the expression under the square root. So let's look at x squared plus 4x plus 7. Just in case you forgot how to complete the square, remember the goal is to get a perfect square. So you need to add a number so that the expression x squared plus 4x and the new number will give you a perfect square. In order to not change the value, you will need to subtract whatever you add here. This term is always half of the linear coefficient squared. So we'll put 4 and 4. And now we see that x squared plus 4x plus 7 after we complete the square is x plus 2 squared plus 3. Now we're ready to get on with the integral dx over the square root of x squared plus 4x plus 7 is equivalent to the integral of dx over the square root of x plus 2 quantity squared plus 2. We're going to use the substitution for the tangent. So looking at what is squared, we'll have x plus 2 equals the square root of 3 tangent. However, we really want tangent theta, sorry about that. We really want to get the x by itself, so we'll write this as x equals the square root of tan theta minus 2. And you can get the derivative. The left-hand side is dx, and the right-hand side will be square root of 3. Tan's derivative is secant squared, so we've got secant squared theta, and the derivative of negative 2 is just 0. So the expression looks like this. Now let's make the substitutions. That is the integral of dx divided by the square root of x plus 2 squared plus 3 is going to be the integral of, for the dx, let's put in square root of 3 secant squared theta d theta, and the denominator is going to get a little bit tricky. So remember that for the x, let's write this for the x, okay, under the square root. X is the square root of 3 times tan theta minus 2 squared. Stop that.